So we're going to continue with the web quest today. We're going to do parts 3 and 4. You're going to have to look at some graph data. So a lot of what the mini lesson today is going to be about is graphing data. Just to recap, we started talking about climate change in terms of the greenhouse effect yesterday. The greenhouse effect has us studying the fact that the atmosphere is like a blanket for Earth. It helps hold in some of Earth's sun's radiation, the heat from it at least, to keep us at a level that can sustain life on Earth. However, with the addition of greenhouse gases, a lot of that heat is not able to be re-radiated back into the out of the atmosphere. So as you can see, in normal conditions, we've had some of the heat strike Earth and be absorbed, and some of it's re-radiated, but with additional carbon dioxide, methane, and water vapor, as well as a few other gases like nitrous oxide, the heat is not able to re-radiate, and that has caused a change in the average temperature of the Earth. These are a few of the molecules here. Water vapor, which you're familiar with, which is part of the water cycle. Carbon dioxide, which we breathe out and plants take in to make their own food through photosynthesis, and methane, which we see a lot of being released from factories, and also is a natural gas that's used for energy, as well as escaping through the process of raising livestock. So greenhouse gases are important. We don't want to have none of them, because with too few of these greenhouse gases, Earth would be too cold for life. However, with too many, it is possible for Earth to be too warm. We want to try and keep those changes small as possible, but over time that's been very difficult to achieve. We've seen a lot of changes in the greenhouse gas contribution, so through combustion at factories and in cars of fossil fuels, we add more carbon dioxide and other greenhouse gases to the atmosphere. Cutting down trees means we're using less carbon dioxide for plants to make food. Decomposition, so naturally when organisms break down and we throw more waste, we release carbon dioxide back into the atmosphere, but also it happens in landfills when we throw waste and garbage into them as well. Let's see, we also have cellular respiration, so organisms such as humans naturally breathe out carbon dioxide. Livestock release methane as a byproduct of digestion. And volcanic activity, so when we have volcanic eruptions, that's a natural source of greenhouse gases. We can see over time, especially in the recent 50 or so years, there's been an increase in carbon dioxide, an increase in methane, although that has started to taper off as many people begin to change their diet and eat less red meat, whether that's due to a change in diet due to health reasons or more consciousness because of the greenhouse effect, could be up in the air. It's not definite that it's one or the other. And overall, there are other types of greenhouse gases that have started to level off over time as well, but have mostly increased in the last 50 or so years. As the water temperatures increase, we went over that the Arctic is warming and that ice is melting as well. So we have to keep that in mind. I'm going to change to part 2. So the sea ice is melting, and as I said, that can be detrimental for organisms like polar bears that live there, as the ice usually reflects the solar radiation. That reflection helps re-radiate some of the heat from the sun back into space through the atmosphere. However, with less ice, the water is absorbing that radiation, and as the water warms up even more due to absorbing the heat from the sun, more ice is continuing to melt, and as the temperature increases, and as that increases, we're now seeing an increase also in the temperature of Earth because the water is pulling in more heat as well. Let's see. So this is a time lapse. I'm not going to show you the whole thing so I don't run out of time at the end of this video, but as you'll see, this is from NASA. It's a depiction of how the ice is disappearing over time. Hopefully it loads. Come on. Come on.
In this animation, we're taking Arctic sea ice into the third dimension. Here, we're looking at the ice age, which is an indicator of thickness, generally older.
So you'll be able to watch this later, but as you can see, this video is going to show you how the Arctic has changed over time and how the ice has started to disappear, causing warmer ocean waters, causing higher sea levels as well. I'm just going to skip ahead and show you some of those changes in the depiction, but you'll get your information from the video later. Let's keep going. This is a graph depicting how over time the amount of ice has decreased. Here we're seeing that in about 1979 we had about 2.7 square miles of ice around the ice caps of Earth, but now we're down to 1.8 million, so we've lost almost a full million square miles of ice over the last, let's see, 30 or so years. Keep that in mind. Now, these changes in the ice are not due to a massive difference in temperature. A rise of 1 degree in a single day is not going to have a big effect in just one area of the Earth, but imagine the whole Earth heating up by 1 degree average over the course of a year. That's what's caused our ice caps to melt, the ocean levels to rise, oceans to warm, different ecosystems to start failing, such as the coral reefs, which I showed you yesterday, that are becoming bleached because the algae that pretty much are the basis for the coral reefs are dying. And because of the changes in these ecosystems, many organisms and different species are starving and beginning to die out. As the sea levels start to rise, shorelines become flooded, the beaches become eroded, oceans begin to warm, causing even more ice to melt. Salt water is intruding into fresh water because it is coming further up the coastlines, which could be harmful to humans, especially in areas where they can't necessarily find a lot of fresh water like we can here. We're also seeing differences in weather patterns, so famine in some areas where we're having less precipitation, forest fires where there's less precipitation. As you probably saw in the news, Australia had some really massive forest fires, or just brush fires actually they would call. California's had many more fires than normal in the last few years as well. Where there's stronger storms, there's flooding, and people having destroyed homes, more waterborne and insect-borne diseases that can be carried by, let's say, mosquitoes, increased amounts of hurricanes, or in tornadoes, or at least the hurricanes are of a stronger grade. On a scale of 1 to 5, many more of them are falling closer to a 5. Here you can see that while the temperature does fluctuate, mainly due to the seasons, over years, the temperature has slowly increased. It's increased, starting especially around the, it started especially around the Industrial Revolution when we started using more fossil fuels such as coal, and saw greater amounts of technology being used, technology that was able to help the human population grow in numbers as well. All of these effects, such as the increased use of fossil fuels, cutting down of forests, in addition to all the natural amounts of greenhouse gases that are released, causing the ice to melt, causing increased temperatures of the water, causing the temperature of the Earth to increase, has changed our climate, changed what we see on a normal basis, just because of a approximate 1 degree average change of Earth's temperature. Let's see. One way they've been able to tell just how much the carbon dioxide has changed over time is we're able to see how much of certain greenhouse gases, such as carbon dioxide, there is in the atmosphere now, but we're also able to see it in the ice from thousands or even millions of years ago. Some scientists go into areas with massive amounts of ice like the Arctic, and they take out cores of ice and they study the composition of the gas bubbles in the ice that form. And they're able to tell how much the amount of greenhouse gases in the atmosphere. This video here will show you exactly how they're able to test the amount of greenhouse gases that there were at a specific time. Overall, they've seen the trends of an increase in the greenhouse gases, and they've been able to correlate it to the increase in temperatures as we've, in the recent last century, started recording weather and temperatures and climate much more. See, we're also able to keep track of just which type of combustion has what has led to more increases in greenhouse gases. So the total increase is the black line. Petroleum is the blue line. It started to increase a lot more as we've started using our cars a lot more and used oil for heating. The red is natural gas. We see that a lot in stoves and using that for barbecues and other energy needs. The light blue is cement production, and the bright green is coal. Coal is pretty much right around the same level as petroleum use, as it's usually used in power plants to give us electricity. We've also seen an intense increase in human population. As human population has increased, it's increased because we've had better technology in medical care, thanks to the Industrial Revolution and many discoveries. We have a lot more waste products because of that. There's a video here that you're going to be able to watch that's going to be a time lapse of the change of humans over the course of Earth and its existence. As you can see, this is starting around the Roman Empire. It's going to take you up to present day, where you're going to see an very large increase starting around the 1800s. I don't want to run out of time on this instructional video, so take your time, but here we're going to see right around our recent years the increase in the human population. I believe we're coming up on 8 billion if we have not already hit 8 billion people on Earth. By about 2050, we should be hitting the 9 billion mark. Before we run out of time, I just want to take you through today's tasks. So you're going to open your new web page tracking the temperature, and you're going to click to explore the data. There we go. You're going to roll your mouse over this. You have questions here, and you'll be able to answer the question. So what does the graph measure? Global annual temperature and CO2, carbon dioxide, so on and so forth. You're going to do each question and answer, and every time you're going to put your number choice in one of these boxes. Then you're going to have your second website after that, and it's going to be another simulation using the different molecules of greenhouse gases. So for example, press start on the right side of the screen to initiate carbon dioxide part of the interaction. Do not click on the molecule yet. Record what you notice on the sun's radiation after it hits Earth. So you'll be able to hit start on the carbon dioxide, and it's going to take you through. So you'll be able to describe what you're seeing here without clicking on anything, so on and so forth. So you'll go back and you'll answer your questions. 17, click vibrating molecule for carbon dioxide. So for the carbon dioxide, you'll start it and you'll click on that.